There are a number of upgrades to object literals in ES6, and these are some that I use absolutely every single day. These are probably some of the more practical things of ES6 that you're going to be using. And this is an example where I've got all these variables, first, last, age, and breed, and I need to put them into an object. So I would say const dog equals, make myself an object, and I go, okay, I need first, I need last, I need age, I need breed. Pop those suckers in there, but like the property names are the same as the variables. So I'm just going to take the property name and paste the variable in there. Now, that is okay, but it's very repetitive because we're doing the same thing over and over again. I've just made an object with all those variables inside of it. If we console log that, you'll see it's just a regular object here. No problem. But what you can do is if the property name and the variable you are setting it to are named the exact same thing, you do not need to do this twice. And that's actually why I'm getting these red lines here. My ESLint is telling me, hey, it's unnecessary. So what you can do is you just take them out. And this may look a little bit weird because like right now, this kind of looks like an array, but it's really an object. But doing that still gives us the exact same object that we're looking for, just without the repetitive property name is equal to the actual variable name. Now, you don't have to go all in on that. That's only when that is the actual case. So like, for example, if you want to like rename it to first name and it would be first, that's no problem there. Similarly, if you want to add just like pals, would be Hugo and Sunny, then that is just a regular array. Only need to use it when the property name and the variable name are exactly the same. So that's pretty straightforward. You can start using that absolutely already. Another update is when you have method definitions inside of an object. Let's say we have a modal object here. So let's say const modal equals, and inside of that we have three methods. We've got create, we've got open, and we have close. And all three of those are functions in which they are just a function. And after each one, we have a comma here. So yeah, we did that on and on and on. However, what you can do instead of doing that is just leave out the word function and leave out the colon. And that is the exact same thing. So create open close parenthesis is the exact same thing as doing colon function. It's just a shorthand. There's no like weirdness with the keyword this or anything. And that's exactly why I said you should not use an arrow function when you're using a method of an object, because we have this other shorthand here and it's not going to monkey with the scoping of any of your variables or the keyword this. So I can just take that to there and that to there. Similarly, if you had any params that you needed to pass it, like maybe a selector here, maybe some content here, and maybe like a goodbye message here, you can just pass them in as you normally would into a function. So those are two big updates to the object literal. A third one I want to talk about is something called computed property names. Now, this is something that you might not use every single day. Good to know in case you'll ever run into a situation where you need it. So let's set up a little example where we have a key that needs to be set on an object. So we'll make a key variable and we'll say pocket color. Why? Because we're going to make a t-shirt here, and the t-shirt has a whole bunch of different attributes about it, like pocket color, main color, ink color, sleeve color, all these things. So we're going to talk about the pocket color here, and we have a value of that actual color. It's going to be set to yellow. Now, we need to use these variables to set a property and a value of an object. So no problem. What we could do is say const t-shirt equals object literal. And previously what we've been able to do is you can say key is equal to the actual value. So let's take a look at what we've got so far. Console.log, the actual t-shirt. There's our t-shirt. The pocket color has been dynamically set. And if I were to change this from pocket color to ink color, see that the variable is now updated to ink color. Great. So we are creating an object literal with it. However, that has always been possible. But one thing that is now possible is, what if we wanted the opposite color to go along with that as well? Because maybe we were printing something on top of that pocket and we needed to know what is the exact opposite color of that so it could go on top of it. So I've got a little function right here that I'm going to bring in, and It's just a function that takes in a hex code and returns the inverse color. So just the opposite color. Now, if I wanted to make a key of like pocket color opposite, how would I do that? I could make another variable here and then say opposite, but that's not really what I'm looking for. What we need to do is we need to compute the copy. So what we can do here is just use a function or a template string or any other JavaScript right inside of the property name. So I'm going to give myself the key and then tack on the word opposite. And that is going to be, we can use this function that I ran here, invert color, and it's going to take the value as well. Now look at what's going to happen. We refresh. Oh, key has already been declared. Oh, because I made two keys here. There we go. Now we've got pocket color and pocket color opposite. Those are being dynamically set on this actual variable. Previously, what you had to do is you would have had to make the t-shirt object and then go and update the t-shirt object like that and like that, which is not the end of the world, but it's kind of cool that we can now do it inside of our object literal. As we define it, we can compute the property keys. Let's look at one more example here where sometimes you have some just funky data that you get in from an API and you don't have too much of an option to work with. Obviously, you would have a little bit of a nicer structure, but sometimes you might have like a keys array, which is like size, color, and weight. And then you have a values array, which is something like medium, red, and 100. And you need to make an object where the size is medium, the color is red, and the weight is 100. You could make an object here where you say const shirt equals, and you could say keys of 0, and that's actually a computed property name here. But one cool thing that you could do is you say keys.shift is equal to values.shift. And then do it once more and again. And whoa, that's the same code 3 times, but what is it going to do? Aha, size medium, color red, and weight 100. What happened here is that we just plucked off one from each of the arrays as we went through. And you can just run the same code over and over again. Obviously, you could have also just looped over them and set it on the shirt after the fact, but that's just another example to show you when you might be able to use computed property keys.